Hello everyone, this is Elisa Baum, Percona's Director of Product Marketing. We will begin in just a moment, but first I'd like to conduct housekeeping as usual. First, please raise your hand using the hand icon located in the GoToWebinar control panel to let me know that you can hear me. Let's see, I see some hands, thank you. Next, during this webinar, you will be on mute, but should you have any questions during the discussion, please go ahead and enter them in the questions field within the control panel. At the end of the webinar, we will take time to answer as many questions as possible, and questions that are most relevant to the topic we're discussing today will be answered first. But those that aren't addressed will be answered in a follow-up blog entry on Percona's MySQL Performance blog. In addition, I'll make sure that everybody gets a recording of this webinar as well as copies of the slide within 48 hours. With that said, thank you so much for attending today's webinar using Performance Schema to monitor and troubleshoot MySQL 5.6, and it's being presented by Principal Architect Alexander Rubin. With that said, I'll turn the floor over to Alex. Go ahead.
Hello everyone, my name is Alexander Rubin, and I will be talking about Performance Schema today in MySQL 5.6. So my name is Alexander Rubin. I was working with MySQL for over 10 years. I started at MySQL AP, then worked at Sun Microsystems, then Oracle, and joined Percona about a year ago. I've been helping customers to improve MySQL performance, doing performance tuning, full text search optimization, high availability, and things around MySQL. So today's agenda is about MySQL Performance Schema in MySQL 5.6, and we will start with to Performance Schema in MySQL 5.6, and then I will show you some real-world examples of how to use MySQL Schema, and we will talk about a little bit about Performance Schema configuration. So Performance Schema is really great, and it was introduced in 5.6, and Performance Schema will help you to get much more visibility in MySQL and help you to analyze MySQL performance and finally improve your application. So here's the couple of slides about the general performance analysis. So what we did before MySQL 5.6 Performance Schema, we used status variables, which are session level and global level. And with the status variables, we can get general information about how MySQL performs. There were a couple of issues with those status variables. First of all, the filters are since MySQL start. So if we need to get an incremental, we will need to calculate the difference. Also, those are per MySQL instance. So there were no breakdown per user, per schema, per database, and stuff like that. Obviously, show engine InnoDB status is very helpful to get an insight of what InnoDB is doing right now. Another thing that we used since MySQL 5.1, 5.5 is show. It was originally a patch that will show you an additional information about per session level profiling. So you can profile any individual query by using the profiles. And then finally, of course, MySQL slow query log is very important to troubleshoot your queries. There were also, if you're using Percona server, then there are some additional details that are logged in the slow query log. For example, you can get some additional information of what kind of things each query execute. For example, for select queries, you can get an information about it will create a temporary table, or if a query will do a file sort. Those additional details are available in Percona server. But will not give us the full information about MySQL internals. For example, if you are running a multi-tenant MySQL server, what you may want to, what you are interested in is per user statistics, per schema statistics, and per table statistics. And this is possible with the new MySQL 5.6 performance schema. For example, if you are hosting MySQL for your customers, for multiple customers, like a cloud provider or a hosting provider, you may want to get a per user statistic and so-called charge per each I/O operations like Amazon do. Or you may want to get per schema statistics and see the most used schemas or databases inside your instance. Or you may want to get the top most used hottest state by I/O, by requests, by number of selects, and stuff like that. This is what MySQL 5.6 with a performance schema can give you. Now the good news is if you are using MySQL 5.6, starting with MySQL 5.6.6, performance schema is already enabled. So you don't need to do anything else. It's already there. For example, if you do show global variables like performance schema, you will see that it is on, unless you specifically disable that. Now another good thing that you got from the performance schema right away is the list of all your queries, like a digest, query digest. That will include all query patterns. Now this is not a slow query log. It's a little bit different from the slow query. If you enable the slow query log, you will get the actual queries. Here you will only get query patterns. But on the other hand, you will get all and every query here. If you enable the slow query log, you will need to choose how slow the query should be to be recorded in the slow query log. Here you will get all queries. And here's just a quick example of what you will get from the events statement summary by digest table. So you can select the digest text and you will see that you will get an actual query, but this query is normalized. There is no data in it. All the data will be masked by this question mark. So you will get the query digest sort of thing. Now, if you open your performance schema, and you will see there are 52 tables in the performance schema, and this is a mix of configuration table and data table. So there are lots of things here: configuration table, object tables, current table, history table, summary tables. So it's navigate and very hard to understand what actually do we need for our reports. So the good news is that the tool called the SYS schema. It's a great tool by Mark Lave, and the goal of this tool is to make the schema easier to use. It's just a collection of the views and stored procedures, nothing more that you will install in your MySQL server. So you will run this command. You can download the SYS schema and run this command. It will create a database. It will create a database called SYS S1, and inside of this database there will be just views which will run against the performance schema. So those are the list of the tables, and you will see that those tables are more human readable, and those are actual reports that you can execute. So let's take a look on some examples here. For the purpose of I will use a real server example. This is the backend MySQL server for our Percona cloud tool, and I get some real-world examples from them. I will share it with you. So let's start with the user-level statistics. The user-level statistics is very important. That has been missing from MySQL for a long time. So let's say we want to get a breakdown by user. For example, if we want to do something like charge for, like what Amazon is doing, and we can simply, if we have installed the C schema, we can simply select start from the user summary by file IO, and that will give us a breakdown per each user, and you will see the actual number IOs and latency in it. What is interesting on this picture is, as we see, the user API 01 has been executed a lot more IOPS than other users. So this is a good thing to notice if you're doing some troubleshooting or some performance analysis, and let's say you have 3 web servers, 3 API servers, and you're load balancing your requests across those 3 API servers or 3 web servers, and you notice that API 01 is receiving much more load. So there's something wrong with your load balancing mechanism, or maybe it's normal. This is a good visibility that you can get now to start your analysis. Now you can also get a breakdown per each statement, or you can a further breakdown per user, per statement, and per counter. So in this example, I get the report per user per select statement. How many total selects has been executed for each user? So in this picture, I also see that user API 01 is executing much more select queries. So there's something in addition that API 01 user and API 01, let's say, web is utilized with. Some additional load that we see right away from this report. Now, not only you can get the per statement analysis, but you can also get the total request, number of rows has been sent, number of rows has been examined, does this select ended up doing full table and stuff like that. So all this you can get from the user summary by statement type. And then finally you can get other statements. You can get the by updates and get information how many rows has been examined, how many rows has been affected. And finally, you can get a breakdown for each user per statement with some additional counters. So here I'm only interested, I'm doing my investigation, I'm trying to understand what kind of additional load did this API 01 server receive. And I'm seeing that it looks like it's doing much more select statement. It's also doing show fields. And it examines lots of rows. Let's talk about the query level statistics. Query level statistics is, I think, one of the most important features of the performance schema, because it will give us some additional information about the query level, which was originally hard to get. So let's start with a statement analysis. So this schema, C schema, has this view called statement analysis, which you can select from, and you can get a lot of information for each query type. for each query digest. So you can get execution count. You can get total latency and average latency and block latency total for this particular query, for this particular schema. But you also will get some additional interesting information like warnings, right? So the warnings in MySQL, if you do an insert, and MySQL had to do some data truncation maybe, or some casting of integers or doubles or something like that, it will issue a warning. And this is the number of warnings. So if you suspect that something is going wrong or you get some data truncation issues, you can just search for queries with warning. Or you can also get the information about the error count, right? So unlike slow query log, this will also record all the queries that were failed to. So it is very helpful. This is actually my favorite with Performance Schema. I've been trying that out a long time ago when MySQL 5.6 was a release candidate. So we want to, for the performance tuning, we want to find all the queries which creates a temporary tables. Sometimes what happens is there may be lots of queries which create a temporary table, but they are fast enough, and they may not show up in your slow query log. If they are not showing up in your slow query log, then it is hard to catch them. But they may add up, and the temporary table which a query will create will add an additional load to MySQL. So now with the performance schema, we can actually find all those things which creates temporary table by just selecting from the performance schema table. So we can see from this report, we can see how many temporary tables has been created in memory and how many tables has been created on disk. And also it shows us a very interesting metric, average temporary table per query. So this query is pretty important. It's can give you a significant load, can place a significant load on MySQL. It's 5 temporary tables per query. Also the percentage of the temporary tables to disk ratio. Another thing that obviously together with the temporary table, we may want to find all the queries which sort, which are doing either file sort or just sort in memory. So this report, start from the statements with sorting, will give us this information, and also include the execution count for each statement, latency, some additional sorting information like how many rows has been sorted, average rows sorted, and stuff like that. That is also very important for performance tuning and performance analysis for MySQL. Another thing that Performance Schema will give you is a better process list. So the process list will include some additional information like how many rows has been examined, how many has been sent, also temporary table. This is for the current process list. Now this is similar, of course, to just doing show process list or select star from information schema process. But as I said, it includes lots of more information that is very useful. And this is an example, another example from running the list from the CIS on the slave server. Another example that we can look is the table and schema level statistics. This is very important, especially if you're running a multi-tenant MySQL server, or if you're running a shared schemas, many customers and stuff like that. This is what we can get from the schema table statistics table. We get the information for each table, and we can get the information about how many rows has been fetched from this table, how many rows has been inserted, how many rows has been updated, and also all IO requests. We can get the information about how many IOs has been read from this table, has been written to this table, and also latency. So if you're looking for and you're trying to investigate some additional load on the system, and you want to get this additional information, then you can definitely look into this. That's called Schema Table Statistics Report. And in addition to that, and this is really, really helpful, you can get buffer pool information. So you can get information about how many bytes has been allocated in buffer pool for this particular table, how many InnoDB buffer pages has been allocated, and all this information will help you in your troubleshooting. And this is my actually another favorite report, unused indexes. That feature has been missing from MySQL for a long time. So the unused indexes is very important if you are trying to, for example, optimize your statistic or optimize your MySQL server. And of course, no one wants to remove the indexes. But some unused indexes, additional indexes, may actually harm the performance, because each additional index that you add to MySQL may slow down your insert, update, and delete queries. And also it may confuse MySQL, so MySQL may start choosing wrong index. So the report will help you to get the indexes that never been used since MySQL start. One thing that I want to do here in this report is to exclude the primary, because primary key in InnoDB is a part of your table. So we definitely don't want to remove the primary keys. So this report will help you to identify the unused indexes in your MySQL server. And then finally, this report will help you in investigation of high server load. This is called latest file IO. Now let's say you're trying to find out what is happening with MySQL, and you see there are lots of IO requests, there are lots of bytes read to disk, and you want to find out why and what is happening. So you can use this file IO table view to get the table that is responsible for the latest input-output in your MySQL, and get this information about total reads in the bytes, average read per request, and stuff like that. Now, one note though is, and we'll talk about configuring performance schema. For this report to run, we will need to enable events waits history long. Otherwise, if you're running with MySQL 5.6 with the performance schema enabled, you will not get any data from this latest file IO. And then this is also useful report if you want to get so-called hot tables that are accessed most. For example, if you know that, again, your MySQL is highly loaded, and you want to see what kind of tables are responsible for that high load. In MySQL Performance Schema, all of this information is obtained on a file. So I assume that you are running your MySQL 5.6 with InnoDB file per table, which is the default in 5.6 as well. So every table that you create, every InnoDB table that you will create will actually be a file on disk, table name.ibd file on disk. So we can from IO global by file by bytes and filter out the files that IBD and get this report. We can get the information about total read, average read, average write, and stuff like that. So you can get information per IO and per bytes as well. And then also we can get the report per schema. Again, if you're running a multi-tenant MySQL server, you want to see which schemas receive most I/O, receive most requests. This is the report that I have created based on the SYS schema tables. What I'm doing is I'm grouping by the schema name. Again, all the information that are available on is per file. So what I'm doing here is I extracting the database name, the schema name, from the full file path, and then I'm grouping by D, by the database name here, and I'm summarizing the bytes. So you can see here we have this pretty high-loaded schemas, which receives a lot of total bytes written and read from it. So now we can see this as our hot schemas, and we can, for example, optimize. Now, finally, I will talk about performance schema configuration. This is not a very straightforward process. Configuring a performance schema may be confusing because there are lots of you can configure. It is also very flexible, though, so you can configure lots of stuff differently. Again, by default, MySQL 5.6 latest have performance schema already enabled. But if you want to enable or disable some additional things, then you can do that. So configuration of the performance schema are split among the different objects. First of all, you can configure things at a startup in MySQL. For example, if you want to configure specific instrument, here we are configuring a weight instrument, then you can add those configuration variables in your my.cnf. So we can, here we want to configure events weights, and we will first enable this instrument so it will be counted. And then second, we want to enable the history for this. So that's, we will add performance schema consumer events weights history equals on. The second thing that we can do is we can enable some additional instrument on the fly. So we can use update and do update setup instruments so they will be enabled and timed. Now, the one of the issues here is that if you do update on setup instruments, for example, then those changes will be lost at start. So one trick that you can do is you can create an SQL file, place the update statement into this SQL file, and use init file statement in UMI.CNF. So this file will be executed every time MySQL will start. And then you can also configure your performance schema per thread. So if you, for example, want to configure a specific thread to record more information, or you can disable some instrumentation for any specific thread you're not interested in, then you can do it as well. And next, you can configure actors. By default, all users from all hosts are profiled, but you can change that, and you can specify a specific host or specific user or even role to be profiled or not profiled. For example, if you know that you want to profile a particular user, then you can do that, or you can profile a particular web server, for example, a developer web server. You can do it as well. And then finally, you can configure so-called objects. Objects are actually tables. So you can, for example, skip some instrumentation for table level. Or you can actually configure more instrumentation for specific tables. Or if you're interested in some log information, you can do that as well. So you can configure on a table level. Now, one of the issues with performance schema is that it doesn't record any increments. So what if we will need to get the top statements for the last 5 minutes? We will need to do it manually. We will need to create a separate schema or a separate MySQL server which will pull information and compute the difference. Now, if you want to flush the statistics for the performance schema, you can use a truncate table that will flush the statistics for this particular table for this particular instrument in performance schema. Now, the overhead is a very big question, and this, I think everyone wants to know how much overhead you have with a performance schema. That is a very good question, and actually very hard to answer that question specifically. The overhead can vary significantly, and it depends upon the workload and configuration. Now, if MySQL is CPU bound and there are lots of statements going on in MySQL, there are lots of contention that performance schema will give you worse overhead. Mark Callaghan originally recorded this as 3% overhead for just having performance schema compiled in, and 11% overhead with the default setting. Now, MySQL 5.6 have performance schema already enabled. Peter Zaitsev has run this sysbench test, read-only, and calculated that there's about 10% overhead for the performance schema, and with the default settings, and 24% overhead with everything enabled. On the other hand, if you were running MySQL 5.6 with a normal setting, you probably will not notice the overhead of the performance schema. MySQL 5.6 by itself have introduced lots of performance improvements and the scalability fixes, so it's a good thing. And unless you're running with a really high-loaded MySQL server CPU bound, you will probably never know any overhead of your performance schema with the default configuration. This is actually how we can enable everything on development server. Let's say we want to provide something and want to determine if we have some bottleneck somewhere, or if we want to provide deadlocking, then we can enable everything. So what we're doing here is, first of all, we will add this in CNF, and we will set the wait history size and history size to pretty large numbers, so we will get more history in it. The last line here in my.cnf actually enable all instrumentation for performance. The second thing that we'll need to do is to enable all consumers. So everything will be profiled. We will do that by doing update setup consumer set enabled equals yes. Finally, we may want to do is to set the timer to be consistent. So we can set this timer to nanoseconds. So in all different instruments, it will use a nanoseconds. That will, of course, will add some overhead. So it's not recommended in a real production system, but if you're running some development system, or if you're troubleshooting MySQL issues, then you can definitely do that, and this will give you much more instrumentation and much more information. So this is some additional information about the performance schema. There are lots of information nowadays about 5.6 performance schema. You can read the manual, you can read some blogs, and you can download the presentation that has been done on MySQL Connect 2012 and Percona Live. So there are lots of information regarding performance schema. And again, if you're using MySQL 5.6, it is already enabled, so just take a look into your performance schema database. You can also download this C schema, and you can start taking advantage of what performance schema will give you. If you're not using MySQL 5.6 though, then we usually suggest our customers to upgrade to MySQL 5.6 because it will not only performance schema, but will give you lots of new features and improvement. So that's all I wanted to talk about today, and I will be happy to answer any additional questions that you may have. Thank you.
Okay, audience, if you have questions, go ahead and enter them into the GoToWebinar questions control panel. And Alex, we've got a couple questions already. With performance schema enabled, what kind of maintenance needs to be done on it?
Right, that's a very good question. So by default, it is taking care of itself. You can configure how long history you may want to store. But if you're not configuring it, then it will basically store about 1,000 statements. If you want, then you can always do truncate table to flush the history. Other than that, it will basically take care of itself.
Okay, next question. Can we delete the temp table data to reduce the space and increase the server process?
Alisa?
Yep, Alex, can you hear me? Alex?
Yeah, could you repeat the question again?
Okay, great. Can we delete the temp table data to reduce the space and increase the server process?
Well, the temp table you're referring to is I'm not 100% sure I follow the temp table data question, because if you are referring to the temporary tables that MySQL creates by itself, then they are created for a query and will be deleted when the temporary table, when this specific query has been finished. Let's say we have a select query, it needs to create a temporary table. It will create a temporary table on disk, but when the query is done, this table will be removed.
Okay, next question. Can you recommend any set of queries or tasks for MySQL performance/health?
So you were probably talking about something like monitoring using the performance schema. I would suggest a couple things here. The first thing is you can download the C schema, look into the reports, and select from the tables that are provided with the C schema. If you're, and it depends upon what exactly you're looking for. If I just showed a couple of examples in the presentation. Another thing that you can do is you can use the like monitoring. For example, we at Percona have the Percona Cloud tools. You can go to cloud.percona.com, sign up, free right now, and you can get some visibility. Now, another thing is Percona Cloud actually can use performance schema to get all the queries. So you can do it that way. I hope I answered the question.
Okay, next question. Will the overhead of performance schema affect the actual statistics recorded?
The overhead of the performance schema is actually it's a asynchronous thing. So what you from extent what you're asking is can the overhead cause some data loss in the performance schema? I think not. I think not. I'm sorry, I'm not sure I follow the question 100% here, but I will definitely feel free to question on the MySQL performance blog, and when I will create this follow-up blog post, you can definitely clarify all the questions and we can discuss that.
Okay. Has there been additional features added to help monitor for injected or malicious monitoring?
Oh, this is a very good question. So as far as I understand, you want to monitor some potential attacks against MySQL and monitor queries. You can potentially do that with a statement digest feature of performance schema, and you can constantly check the statement history table and search for specific patterns. If you notice that there's some patterns here, then you can take your actions. That's a similar to, but there's another way of doing it. Actually, you can use audit plugin instead, and use an audit plugin to audit your MySQL installation and create a XML.
Okay, the next question is, if slowness or any issue is reported on the database by the users, what tables on performance schema, or how can we use the performance schema to find out the issue at that point of time?
Yeah, that's an excellent question. So what I would start with is a couple things. First of all, I will look at the most frequent queries in the most frequently accessed tables. So, and then we can go from there. And usually the slowness are caused by either the disk IOPS, if MySQL lots of flushes on disk or lots of IOPS, or specific queries. We can definitely look at the specific queries and look at the report from the performance schema to find out the queries which, for example, creates temporary table or file sort and stuff like that. And this will be our starting point.
Okay, next question. What needs to be enabled apart from default settings on Performance Schema to get the info on what is causing the slowness or overload on the database?
Well, I think that you can start with your investigation by just with the default. You will get the list of queries out of that, and you can basic IOPS out of that. If you would like to get more visibility, then you can enable the query history, and you can enable more history, basically a longer history in the queries. I would start from that.
Is there a way to connect the performance monitoring to Cacti?
That's an excellent question, actually. I don't think that anyone did that, although I am not sure. Of course, it's possible to do that, and you can create a custom graphs based on the performance schema. But I'm not sure that there are templates based on that. As I said, Percona Cloud Tool utilizes the performance schema for queries. It can collect queries from there. But there are lots of stuff that you can graph and monitor out of the performance schema, and you can use Cacti, you can use Graphite, stuff like that. But you will need to create your own scripts based on that.
Okay, next question. Do you know of any efforts to reduce the overhead of Performance Schema in future releases since it is enabled by default?
Yes, I know that there are lots of work going on to decrease the overhead of the performance schema. I'm not sure what will be actually. Hopefully, in MySQL 5.7 there will be some reduced overhead in the performance schema. And in MySQL 5.7, actually, there are some additional features has been already worked on in performance schema, which will allow you to get a break for memory utilization. So that is very useful if you want to troubleshoot some memory leak.
All right, next question. How would I use the Performance Schema for index tuning?
This performance schema can be used by for index tuning. First of all, you can get the information about the used and unused indexes, the number of IOPS per table, and finally you can get the list of queries which will hit any particular table that you're interested in, and see those queries are doing things in MySQL, like if the temporary table or not, and stuff like that. And then you can finally do explain on that and tune your indexes. So this is similar to what we did in older version by using MySQL flow query log, but now we have some more instrumentation.
Okay, I think we'll take a couple more questions. So the next one is using sys schema recommended by you? Does it cause any overhead or issues on the database if we enable it?
No, the sys schema itself is just a collection of views and stored procedures. So if you create this sys schema, then it's basically, and you select from inside of the sys schema, it will be executing a query against the performance schema. Now, and good thing about the performance schema is that performance schema is non-blocking. So if you select something from the schema, it should not affect MySQL performance. So sys is not an overhead at all. It is just the collection of views. I would say it's pretty safe to use.
Okay, Alex, I think that's it for questions today. I wanted to thank you for a great presentation. Audience, thank you for joining us today. The next webinar that we have is August 27th, and it's on using GTIDs, Global Transaction IDs, in production. We hope to see you there. Also, just remember that I will be able to send you a recording of this webinar and the slides within 48 hours. And with that said, audience, thank you so much for your time today. Alex, thank you. Great job.
Thank you very much, Elisa.